Okay, guys. Sorry I'm not there. We're still going to try to do notes as best we can while I'm gone. Good news is we're not doing really anything new. Same two formulas yesterday. We're just doing more practice problems. Maybe a little tougher problems, but same formulas. Okay, so as you're doing this, of course, you should be taking notes with me, just like if I was there. You're following along, you're writing it down, and most importantly, you're working in your calculator with me. Because like I've said before, I know I sound like a broken record. I see so many people set these up right, but then miss points because they type it in their calculators wrong. So make sure you're doing it along with me. Okay, let's jump in. At the beginning of an experiment, a culture contains 1,000 bacteria. 5 hours later, there are 7,600 bacteria. Assuming that the bacteria grow exponentially, how many bacteria would there be after 24 hours? Okay, so for starters, I know if I go back to yesterday's notes, that a growth problem, like bacteria, let me get a pen here, is my PERT formula. So we are growing. Okay, so I'm going to write that down. So I'm a good little mathematician, so I'm always going to write down my formula every problem. Now, I want everyone to listen very carefully because this is super important. This would be all eyes on me if I were there. If you are not given a percentage rate, it is automatically a two-step problem. So if you are not told 5%, 2.4%, 8%, you have to find the rate first, then answer the question. So this last question, the actual question they asked me, I'm going to completely ignore until I find the rate. Then I'll answer that. Okay. So I'm going to start. I have 1,000 for P. It's my initial amount. Now they kind of give me this seems random sentence here. 5 hours later, there are 7,600 bacteria. They give me this like 1 moment snapshot to find the rate. So I'm going to use this as my A. And then 5 is my T, so I'm trying to find R. So let's divide by 1,000. Over here I get 7.6. Now to undo E, I'm going to take the natural log. So I have the natural log of 7.6 equals 5R. Divide by 5. So R is the natural log of 7.6 over 5. Now, we want to leave it like that. I'm going to write it down here. Whoops. If it lets me scroll down. Don't round. If you round even a little bit here, we're going to use it in a minute. It's going to make your answer be off a lot. Because remember, exponential curves grow very quickly. So if I round just a tiny bit, it's going to affect it a lot. Okay, now let's answer the questions. I'm going to start all over. A is P e to the RT. Let me get a different color here. Okay, I've used this. That was used to find the rate. I'm done with it. Now my initial is still the same, so I still have 1,000. That doesn't change. But now I know what R is. R is natural log of 7.6 over 5. And then they want to know how many will there be after 24 hours. I'm going to plug 24 in for T. So I'm trying to find A. Now, before we keep going, let's think about our units. They said, how many bacteria? Well, bacteria is a living thing. And there's always somebody that likes to argue with me, but there's no exceptions here. Living things don't have decimals. So what we do is we round down to the nearest whole number. Always round down. So let's go ahead and everybody grab your calculators, type this in. I got 16,907,021. And it's really 0.4, but you round down. Even if it was 0.9, you still round down. Okay? And that is bacteria. So living things, you round down to the nearest whole number. This is a very typical bacteria problem you would see where you have to find the rate. Let's do another. Population. I said this yesterday, I'm going to say it again. So many people, even though it directly says in notes that PERT is for population, I don't know why they choose to use the wrong formula. But we're going to be good little mathematicians. We know which formula to use, and I'm going to write it. It says in 1975, the population of a New York suburb is approximately 125,000. By 1990, the population had boomed to 160,000. How many people lived in the New York suburb in 2005? Okay, notice they do not tell me the rate, which means I'm going to ignore this final question for now. I'm just going to focus on finding the rate. So we started with 125,000, so there's the P. In 1990, we got to 160,000, so there's my final amount. Now, from 1975 to 1990, 15 years have passed. So I have 15 times R. Let's divide by 125,000. Excuse me. I got 32 over 25. Excuse me. Natural log both sides. So I have natural log of 32 over 25 equals 15R. Divide by 15. So I have R equals the natural log of 32 over 25 over 15. Again, don't round. We don't round to our final answer. Okay, now let's go back and we're going to rework the problem, but with our new information. So I know my initial, I'm done with this 1990 statement. My initial is still 125,000. That does not change. I know my rate is natural log of 32 over 25 over 15. Okay, now it says how many people lived in the suburb in 2005? Well, from 1975 to 2005, 30 years have passed. And again, let's think about our units. How many people, living things? So we're going to round down. So everybody type that in. Be careful when you type in that exponent, because that's where a lot of people mess up. Oh, I got a nice neat whole number, 204,800 people. But again, we would round down if it had a decimal. There we go. Let's try another. Good old half-life. I want you to star this. Okay. You will need to know how to do a half-life problem, either on the quiz or the test, or maybe even both. But I'm telling you right now, it is going to be on an assessment of some kind. Okay. The half-life. Now let's think back to our chemistry days. Half-life is the time it takes for half of a substance to decay. So for instance, you're old like me and you're nerdy, you worry about drinking caffeine. But when you worry about drinking caffeine and you're nerdy, you look up what the half-life of caffeine is, which I did a few years ago. So it turns out the half-life of caffeine is approximately 5.7 hours. So when you're young, you can drink your caffeine and still sleep at night, but I'm sure you've heard your parents say they can't drink coffee after a certain hour. And when you pass 30, trust me, you won't be able to drink caffeine as well as you do now. But so that means if I drink a Mountain Dew in the morning, 5.7 hours later, only half of that caffeine is out of my system. And then another 5.7 hours, so we're looking at over 11 hours right now. Another half is gone, which means 3/4 is gone. So that's still in your system quite a while later. So that's what half-life means. Half each time, half each time, half each time. Okay, so whenever I see half-life, I stop reading. The second they tell me what the half-life is, I know I need to find the rate. Because a half-life is not a percentage rate. I'm not even going to read on the rest of the question. So I know my formula is a decay problem. Half-life is decay. So there's my PERT. Now, I could read on and use the 20 grams, but I'm not going to because you may not be given that in other problems. What I'm going to do is I'm going to pick anything I want. The easiest thing to pick is 2. And then half-life means half of that, which is 1, will be left when I plug in 3.6 for t. Now, you can pick anything. You can pick 10 and 5. You pick 20 and 10, 150. It does not matter what you pick as long as you have that pattern of half of it is gone. Very similar to the problem we did yesterday where we doubled it. Okay. Divide by 2. Natural log. And I'm going to go ahead and divide by 3.6. So I have natural log of a half divided by 3.6. There's my rate. Now, once again, don't round that rate. Now that we have our rate, I'm going to go back to the problem and answer the question. How long will it take 20 grams to decay to 3 grams? Well, if I start with 20, I want to know when I end up with 3. I'm done with the whole half-life part, but I have my rate, natural log of a half over 3.6, and you're looking for the t. So unlike the last 2 problems where we just had to plug and chug on the second half, we actually need to solve for this on this one. So I'm going to divide by 20. Natural log. Okay, this is where people mess up. I need to divide both sides by that natural log of a half over 3.6. So it's a mess. What I recommend is when you put this in your calculator, put this bottom in parentheses. Because what people tend to do is they tend to get their fraction bars mixed up in their calculator. And it won't let you type something in, or it's giving you something ridiculous. So I want everyone to type that in. That's a 3.6, by the way. Because this is the one particularly that a lot of people mess up, especially their fractions. And that controlled divide should be your best friend here to enter in the fractions like they're supposed to look. I got 9.853. And we are in time, but the time in our problem is days. So we are in days. And again, sorry, my pen's doing something weird here. 3 decimals. Unless it's a living thing or money, we always want 3 decimals. Okay, so again, flat out telling you, you need to know how to do a half-life problem. So start this one, study it, ask questions on it if you need help. You need to know it. So let's try another half-life. The half-life of meschaconium is 286 years. If you have 10.2 grams in 2000, how much will there be in 2500? Okay, so the second I read half-life, I stop reading the rest of the question. I know that means I need to find my rate. So A equals P e to the RT. I'm going to pick anything I want. I'm a creature of habit. I tend to pick 2. Half of that is 1 in 286 years. Times the rate. So divide, I get 1/2. Sorry, my pen is doing something really weird, guys. So I'm going to take the natural log of both sides, divide by 286, get the natural log of 1/2 divided by 286. Okay, now I'm going to actually work the problem and answer the question. Oh, it's not letting me do anything curvy. I don't know why it's doing that. Okay, if you have 10.2 grams, so there's my initial, In 2000, how much would there be in 200, 500, or 2,500? So I'm looking for the final amount. By now my rate is natural log of 1/2 over 286. Now time-wise, 2,000 to 2,500, 500 years. Now you have to be consistent. If I use years up here, I better be in years down here. So let's type that in. Before we do, it says how much will it be? We're talking grams, so that means 3 decimals. So everybody type that in. I got 3.036. If it'll let me write that. We're talking grams. Okay. Okay, let's try another problem. A few more. In the beginning of an experiment, a culture contains 5,000 bacteria. 9 hours later, there are 7,840 bacteria. Assuming the bacteria grow exponentially, how many bacteria will there be after 1 day? Okay, it's a growth problem, so I know it's my PERT. Let's try it. Just trying to get my pen to work a little better. Okay, so I'm not told the rate, which means I need to use this random fact of 9 hours later to find the rate. Ignore the final question. So I know I start with 5,000 bacteria. 9 hours later, so I'm going to plug in 9 for T. I know it was 7,840. Let's divide by 5,000. Bear with me. Like I said, my pen is just acting up right now. Let's type that in, reduce. I got 196 over 125. That's an E, believe it or not. Natural log. I'm going to go ahead and divide by 9. So R is natural log of 196 over 125 all over 9. Okay, now let's answer the question. So I'm going to go back and restart the problem. I know there's still 5,000 to start with. I now know my rate is natural log of 196 over 125 over 9. Now, 1 day, a lot of people are like, oh, T is 1, but be careful. We used hours the first time, so you have to be consistent. So it doesn't matter if you use hours or days as long as you use the same on both places. So I'm going to go ahead and change that to 24 hours for 1 day. And A, now keep in mind we're finding bacteria, which is a living thing, which means we round down to a near whole number. So go ahead and start typing. We got 16,591. That is bacteria. Hopefully you got the same thing. Sounds about like my house right now. Okay, sorry I had to pause the recording real quick. Phone call from the doctor. Fun. Okay, let's try another one. Last one, I believe. In 1999, the population of Pi City was 14,700. And in 2009, it was 18,200. Estimate the population in 2019. Okay, so population, again, is our PERT formula. I'm going to ignore this final question because I need to find the rate. So it initially was 14,700. 2009, it had boomed to 18,200. Now, between 1999 and 2009, that's 10 years. So let's divide. Let's see what that reduces to be. I got 26 over 21. So I have natural log. Go ahead and divide by 10. I have R is natural log of 26 over 21 over 10. Okay, now let's solve the problem. So I'm going to go back up and restart it. Estimate the population in 2019. Now I'm done with the 2009. Use it to find the rate. My initial is still 14,700. I now know my rate. Now, from 1999, which was my initial time, to 2019, 20 years have passed. Okay, so let's type that in. Now, keep in mind, population, we're talking people. Okay, so make sure you round down to a nearest whole number. Oops. I got 22,533. Once again, I always round down. That is people. There we go. Okay, so homework time. Your book does not have a whole lot of practice on this. Actually, I need to pull up my OneNote. So it will be in your OneNote. I have a handout for you. But make sure you're working on the correct one. I have some people do the wrong assignment. Please don't do that. It's longer anyway. You don't want to. Okay, hopefully it's pulling up here. Okay, so in your OneNote, you're doing 5.2 day 2 homework. Please don't do 5.6 practice. You're doing 5.6 day 2 homework. Notice you have a QR code to check your answers when you're all done. Last I checked, it was working. So, of course, don't try to cram it in the page. All work is neatly numbered off to the side, like usual. Okay, so the rest of the time, so you have time left. So the rest of the time, oh yeah, you have lots of time left. What, 25 minutes at least? So make sure you're working on your math homework. If you finish that, you can work on something else, but make sure you're working on math homework right now.